So welcome to Doing Security Right on AWS, how not to end up as a cautionary tale on the register. So it's going to be a bit of a whirlwind tour through everything that I think you need to know, from kind of first setting up an AWS account, securing it, and then all the way through to trying to build a secure and resilient web app using all the tools that AWS offers. So who am I and why do I think I'm vaguely qualified to talk to you about cloud security? So I'm Jerry MacDonald. For the past 4 years or so, I've been working in InfoSec and specialising in cloud security. I started off at an Edinburgh startup that some of you might have heard of, called ZoneFox. We made a cybersecurity product to help protect against insider threat, so people accidentally or maliciously taking data out of your business, things like that. I was the lead for cybersecurity there across the whole business, and I designed taking our application and turning it into an AWS SaaS platform. Then in 2018, ZoneFox got bought by Fortinet, who are a big US cybersecurity company. They cover all sorts of areas, firewalls, endpoint protection, things like that. And we got rebranded as FortiInsight. So now at Fortinet, I'm the head of security for FortiInsight, and I work on securing the software as we build it and also running it on our cloud platform. So what are we actually going to cover? First up, there's 3 fairly equal length sections that might be of interest to different people. So to start with, how do you actually get started with an AWS environment? Kind of for those of you who've not yet done anything with AWS, or you've got some basic stuff and you want to know how you should be doing it and structuring it for real world usage. Secondly, what tools you should be using to actually secure the accounts, for kind of security engineers and people with an interest in securing the environment. Talking about the foundational services that we need to know about, or at least the ones that you need to know exist. And then finally, we're going to combine all that and talk about building a secure and resilient web app, kind of for people like devs and security architects who are interested in building something in a cloud-native way. And remembering at that point that security isn't just all about stopping the hacksaws and keeping your secrets, and what other things you need to consider along the way. So I'm assuming that most people here have no knowledge whatsoever about AWS. So I'm going to use a few services in my examples that are coming up. So just in case you're not aware of them, I'll quickly explain what they are. EC2, the Elastic Compute Cloud, is the VM running service essentially for running virtual machines on a variety of hardware, from anything up to hundreds of cores and terabytes of RAM. S3 is a simple storage service. It's basically just fairly cheap and durable file storage in the cloud. And then IAM, Identity and Access Management, which defines all of your permissions across your accounts for users and the resources that you have running in them. It's also worth knowing that AWS is split geographically into regions. So there's 22 regions across the world that you can provision your infrastructure into. And generally you'll use the one nearest you, or any specific one that you need to for compliance reasons or something like that. And then each region is split into availability zones, which are clusters of data centers that are close enough to each other they can have low latency links between them, but far enough apart that a natural disaster or something isn't going to take out multiple AZs. So AWS don't actually publish the location of their availability zones, but WikiLeaks do. So here is a mock-up of the kind of example spread that you would have for a few different availability zones around Dublin and the Ireland region. Paying for stuff on AWS is just based on the resources that you actually use, so it's not like a kind of an upfront monthly subscription or anything. And it's generally fairly straightforward, so storage is billed in gigabytes that you use each month. Compute would be billed as minutes of usage that you have each month. And it's all just pay as you go, so you see how much you're spending as you go along. And if you do fancy getting started, there's a 12-month free tier that kind of has some restrictions in it. It's not just everything's free for a year, but at least gives you some resources to play around with for not much cash. So the first section, let's begin by actually designing the environment that we're going to build and getting started. And you can see here, to truly secure an AWS account, you must add more AWS accounts, which will make more sense as we go through it. So the base level of knowledge, I'm assuming, as I've said, is that you know nothing about AWS, and if you've done anything, it's just set up an account. I'm not going to go through the steps for that because it's pretty straightforward, and I don't think you need to walk through it. So we've got an AWS account. Will be your first of many. We'll come to that. and you're logged in with what's known as the root user then. So the root user is much like root on a Linux machine. It's a really highly privileged account. You can do anything. There's no restrictions, including deleting all of your resources in the entire account. So obviously that makes it a really high value account. We want to take steps to secure it, and you're not going to want to use it just day to day for kind of your casual administration. And as I said, the first of many accounts thing, it's worth just bearing in mind, or keeping in the back of your head that you might want to end up with multiple accounts. So for that reason, it's worth making sure that the email account you use to sign up to AWS is nice and secure, because eventually that is going to be something that could let you into the entire setup that you build if that gets compromised. So we logged in with the root user. We want to set things up so that we don't have to actually use it again, because the best practice is to just stop using it, basically. So first things first, AWS generates access keys and secret keys for that root user, which are kind of like API keys you can use for command line tools or your application or whatever, running in that context of their master admin. So it's a pretty bad idea. So the first thing you need to do is delete those keys. It is an AWS best practice. The first thing to do is go in and delete them. I don't know why they put them there in the first place when the first thing you're supposed to do is delete them. And then once you've done that, you want to turn on 2FA for that root account, which AWS call multi-factor authentication, which is really key for protecting that master account. So the best way to do this is with a hardware token like a YubiKey, and literally keep it in a safe. It's a really important credential that you're going to have to use. Or if you're going to use a 2FA code generator app, keep that little QR code that you get for it in a safe, build a fireproof safe, put it in a bunker, whatever. It's the most important set of credentials that you're going to have for your whole environment. So it's really important that you have them secured. So if we know that we don't want to use the root user account, what is it that we're supposed to use instead? We're going to create an admin user now that we can use for daily activity. And to get started with that and understand that, we need to know more about IAM. So IAM is one of the foundational services for AWS. It stands for Identity and Access Management, and basically defines what your users and resources can do and how they can interact with each other. It can get kind of as complex as you want it to be, so I'm going to try and just give a broad overview of all the key parts to give you an idea of how it can be used. It's important that you don't think of users as just real people, but also the resources and services and how they will interact with each other. And it's also worth noting that it's free of charge, so you don't need to skimp on having like a kind of good and secure permission set up just because you don't want to pay too much cash. So there's several key constructs that are used within IAM that you need to be familiar with. A user, like an individual or an application that you're going to grant access to your resources, and groups, a collection of users with the same permission, so it's fairly self-explanatory. A policy, where you actually define the permissions that you're going to use, and I'll show an example of that in a second. And a role, which is again really important. It's an AWS construct that lets you give something running in AWS, like an EC2 instance, permission to do things to act on other resources without you having to manage access keys and secret keys, just giving that responsibility to AWS to do it for you. So, as we said, the policies define the permissions that you're giving, and are comprised of a bunch of different sections. Not all policies will have all of these sections, but all of them will have a selection of them. So, the key parts being a principal, which is like who is doing this. It's either going to be an IAM user or a role, most likely. An action, the thing that you're actually trying to do. So that could be reading a file from S3, it could be launching a new EC2 instance, something like that. The effect, it's quite powerful that you can both allow and deny things, so you can build quite complex policies to explicitly deny things in some occasions and allow them in others. The resource, what thing you're actually acting on, what's being affected. So it might be a file in S3, a whole folder in S3, or just like a specific EC2 instance. And finally, a conditions clause that you can get real complicated with really quickly, to build really specific conditional policies that apply to just your use case. So maybe restricting a user's activities to only being from a particular IP address, or you could use tags, which are like key value pairs that you assign to resources, to restrict your abilities to only be able to terminate instances that you personally have booted up. So understanding how the IAM kind of stuff all works and how you build out policies that cover exactly what you're trying to do is really useful if you're trying to build a secure environment, so it's worth putting a little time up front into learning about. So this is what an IAM policy looks like. It's a really straightforward example. So if you gave this to a user, they would have permission to put new files into a bucket, retrieve files out of that bucket, and then delete objects from that bucket as long as the bucket was the Securi-Tay bucket. So in an ideal world, you would just give the permissions to someone that they actually need to complete the task, so least privilege. But working that out can actually be quite hard. You will find a lot of official AWS tutorials that start by just giving an EC2 instance full admin privileges to do anything they want. And while that's bad, it's because it's really tricky to get right, even for the experts. But at the end of the day, you're trying to get as close to least privilege as you possibly can. So obviously, by this point, we can see that IAM is going to be a really powerful tool and it's going to be important. But it kind of sucks if you're going to have to write JSON manually every time for everything that you're wanting to do. So this is where the managed policies come in. So what these are AWS has come up with hundreds of predefined policies that cover common use cases that you might want to do. So be that full admin access or the ability to have full control over EC2 instances, read-only access to S3, lots of kind of common use cases. So you can use them to help you get started. You can significantly reduce the permissions that you give to your users just by using these managed policies that are already there for you. And that can kind of boost your security a little bit without too much effort. When you do start to want to get specific, the IAM policy generator is a nice kind of GUI tool that they have where you just have lots of tick boxes for all the permissions, and it will help you build the JSON for you. So let's talk a little bit more about roles. So a kind of an odd but pretty accurate analogy is to think of an IAM role like a hat that gives you special AWS permissions. So a role will have a collection of policies, like we've just been over, that give you permission to do things. And then you or an AWS service or resource assumes that role, which is like you putting that hat on and suddenly you have all these permissions. So if you gave an EC2 instance a role that had permission to read files from S3, then applications running on that instance would be able to read files from S3 without you having to write any code to do the authentication or manage the credentials, the access keys and the secret keys. So they give you temporary credentials that are quite short-lived. Generally, you can configure it between about 15 minutes and sort of 36 hours. And after that period has elapsed, AWS rotates them for you and your app just requests a new set. So even if those credentials do get compromised, they'll be rotated pretty soon anyway, so the impact isn't as significant. And most AWS libraries or SDKs that you might end up working with for your apps, they support these roles by default anyway with no configuration. So if you don't supply explicit credentials to your app, then it will look in a role and it will pick up credentials from there without you having to do anything. And they do work cross-account as well if you've got a dev environment and a prod environment and you want to do work between the two of them. So let's take an example of an application that's running on an EC2 instance and you want to access some files in S3. So here we're not using roles. Instead, we've got an access key and a secret key, and it's configured somewhere on our server. Worst case, you've like hard-coded it into your actual app. Hopefully they're kept more securely in like a config file or something like that. So what's going to happen here is your app takes those credentials and it will use them to authenticate an API call over to S3. S3 is going to be happy with that and it'll send your data back. So that seems quite straightforward, but we've had to come up with a way to store those keys securely. And if we screw up and they do get compromised, we're going to need to come back and either make changes to our app or changes to the infrastructure itself to rotate those keys, which kind of sucks. So in this example, we're going to use roles for it. So it looks a little bit more complicated to start with, but actually the complexity, instead of it being on us, we've handed it over to AWS to manage for us instead. So the instance that's running your app now uses its role to request a set of temporary credentials, and then your application will use those temporary credentials to authenticate to S3 for you. So bearing in mind these temporary keys get rotated really quickly, maybe even every 15 minutes. If they're somehow stolen, it doesn't matter as much because the impact is reduced by the fact that AWS rotate them all the time for you. So because of the simplicity of dealing with roles instead of the hard-coded credentials, you should be using them instead of the access keys and secret keys wherever you can. So Now that we've gone over a bit about roles, let's give an example about why making them least privilege is more important. So in this example, kind of similar, we've got an EC2 instance, it's trying to get files out of S3, but in this case, the EC2 instance has been compromised, probably because we've left SSH open and it has a stupid default password or something. So we've given it a least privilege role, so it can access files from S3, and that's all it can do. So if someone's compromised the instance, they're using the command line that's on it to request some files out of S3 from that bucket. That's going to work, but that's okay because the instance already had permission to do that. That's what we're intending the instance to do. But if they then try and use the credentials on that instance to spin up some new EC2 instances, then that API call is going to fail because they don't actually have the IAM permission to do that. So let's now change the scenario a bit. So the compromised instance has an IAM role that just grants it full admin access for everything. And let's put ourselves in the shoes of an attacker who has compromised this instance. So maybe the full admin access got added when devs were trying to debug an S3 issue and it just never got taken away. It's quite common. It's the sort of thing that's easy to overlook. So we're going to use the command line again, request some files out of the S3 bucket, and that's going to work because the IAM permission lets them do that. But now we can also try and spin up some EC2 instances, but that's also going to work because they've got full admin. So your attacker might not care about being stealthy at this point. They've maybe taken a calculated guess that if you don't manage to secure a single EC2 instance, you maybe don't have extensive security monitoring in place. And the first you're going to know about this is when you get your bill at the end of the month and it's like 10 grand. So bearing that in mind, we're going to use the command line, spin up 47 massive new instances, and because we have full admin, we're going to get them all to boot up from a boot drive that we're hosting in our account. So as soon as they boot up, they start mining cryptocurrency and they're sending that over to us. But not at our expense, obviously. But now we've got this nice little source of extra income. We don't want to lose it if somebody finds out the vulnerability in our original instance and closes that down. So we're going to make a little insurance policy for ourselves and create a new IAM user so that we can log into their console and do even more if we want to. So it gives us a more kind of concrete foothold over the account. And at this point, maybe we decided that we don't want to make it too obvious, but because we have full admin, we can list all the users that are already in their account and give it a really similar name so that when they're looking for stuff, it just doesn't show up. So hopefully that's an example of why it's really important to use least privileged stuff, even for something as basic as just a web server, because you might be affected by it further down the line. So now we've had a kind of whirlwind overview into how to use IAM, which will hopefully begin to join up and make more sense as we go through the rest of the talk. We're going to cover this idea of multiple accounts. So it's a weird concept. All we've done is create our account. We've not put anything in it yet, and we're already talking about adding more accounts. Basically, having multiple accounts lets you structure all your resources in a way. So for security, it minimizes your blast radius. So in other words, if you screw something up totally in dev, it's much less likely to impact stuff running in prod if you've got a whole new account for it. And similarly, if resources in one account get compromised, it acts as a boundary to help you contain that compromise. And then in a business context, it's also helpful and much easier with multiple accounts to be able to easily split out costs for dev or prod, as well as any kind of supporting services you might be using like Securi-Tay or monitoring. So there isn't really a wrong way to have multiple accounts, which is nice. The structure just has to make sense for what it is that you are trying to do. And you don't need to get it right first time. You can keep adding new accounts for as long as you like, as long as you've thought about how it's going to work a little bit up front, and you've designed it to be extensible. So we're going to start with a basic one account environment. We're going to use that for our user management, our dev work, all the hosting, all our production stuff, and also all our security monitoring and logging as well. But suddenly your app now has enough users that it's critically important, and you don't want your dev work to screw up its availability in prod. So let's add another prod account, and we'll pull out our production environments and stick them in that. However, now that it's started to become successful, your investors are on your back about your running costs. They're too high, and you need to be able to give them up-to-date information about how much your prod stuff's costing versus how much you're spending on the development of it. So let's pull the active development out to a new account just for billing. And now that you're running a successful application, you've decided now is the time. You need to take security very seriously. So you want to avoid the scenario where compromising a dev or prod environment means that you lose access to the monitoring and logs for that environment. So we spin these out into another account that only the security team would have access to. So how do we actually implement this? Well, a little while back, AWS introduced a tool specifically for managing a whole host of accounts in your organization that they've geniusly named AWS organizations. You create an organization, and from there, it's really straightforward to create new accounts and add them in, and it just comes under the same consolidated kind of billing thing. So it's really straightforward. And at this point, it's a good time to think about how you want your user management to work. So the best practice way of doing this is with IAM roles. So you create roles in your accounts that have permission to do the things that your users need to, and then you log into your kind of main account with your IAM users or your single sign-on provider that you've set up, and then the users assume roles in those child accounts, and they can then carry out work in that context. So you're probably going to end up with something that looks like that. So the design just needs to be something that works for you. You can have as many accounts as you want. It's not uncommon for large companies to end up with hundreds or thousands of accounts. If you have loads of products and each one of them has a dev environment, a QA environment, a prod environment, the number can balloon really quickly. But you also need to think about who can actually get access to what account, kind of in the whole least privilege thing. So your master account is where the billing happens for all of your sub-accounts, and you can get a breakdown of that and actually pay your bills. So we're going to give the finance team access to that one, but they don't need to be able to manage the actual technical aspect of the organization. So we're going to restrict their IAM permissions just to the billing stuff. And then underneath that, we can add child accounts and grant teams appropriate access to that based on their job role. So now that we've gone over the idea of having multiple accounts, we want to talk about how you will actually secure those accounts, and the things that you need to do to set them up. So I'm going to go over some of the tools and services that you can use across kind of key security domains within AWS. The main ones: logging and monitoring, encryption, and a little bit of networking. Touch on what features are worth turning on, what services are worth using, the best practices for some of them, and then a couple of deep-ish dives into some interesting parts of the tech to see how it actually works. So before I begin going through all the services and the different security domains, I want to touch on actually how you should do the implementation of the setup of this. We know we're probably going to end up with multiple accounts. We know we may well doing stuff across multiple regions. So whatever configuration we have, we want to make sure that it's easily repeatable into all our different accounts and regions. And for this, you're going to want to dive into infrastructure as code. Has anybody heard of that before? Okay, a few people. So if you've not come across this concept before, it basically means that you write up your kind of desired state for all of your resources in your accounts, and then you have a tool that applies it to your accounts for you. So there's quite a few benefits to this. You can version control it. So your infrastructure version for a specific version of your app can be in Git alongside your app. And that means that people can review it before you implement it and deploy stuff. You can run security scanning tools on it, kind of like static analysis, linting type things. So you can pick up where you've deviated from best practices, or maybe you've unintentionally left ports open in security configurations, things like that. And it also means you can really quickly roll out that infrastructure across multiple regions or accounts. So one example of a tool that you can use for this is CloudFormation. So AWS make this. It's an AWS made tool with worse than you would expect support for actual AWS resources. And as long as you're not trying to do something really complicated, you'll probably find that it covers your use case just fine. You write it as YAML or JSON. I'll show you what it looks like in a second. And it's just worth bearing in mind, if you're going to come up with something crazy complicated, you might eventually outgrow it. So here is a little example of what it looks like. So this is some YAML CloudFormation, and it's a really basic XOut that deploys an EC2 instance. So you specify the instance type, which is kind of like the hardware requirements, your spec of the actual instance that you're deploying, a key name for an SSH key that you're going to use to connect to it, and an ID of the image that you're going to use to boot this up from the AWS Marketplace, which here is just a basic Ubuntu image. The next thing it deploys, Instance Security Group. It's kind of like a firewall. Think of it like that for controlling what traffic will actually make it through to the instance itself. So here we've allowed SSH traffic over port 22, but only if it's coming from the source IP 1.2.3.4. So writing this up as infrastructure as code like this, it saves us a bunch of clicks through the console to provision all this stuff the first time, but the key comes from when you want to do it the second time, or the third time, or the 400th time, because you can reproduce this exact configuration really easily, and somebody can review it before you deploy it as well to make sure that you've not done something crazy. So obviously there's a whole host of benefits to using infrastructure as code, and you should really be trying to use it wherever you can. An alternative that you might use to CloudFormation is a tool called Terraform from HashiCorp. It's a bit of a steeper learning curve than CloudFormation, and it's a little bit trickier to use, but it has a much wider range of support for AWS resources, so if your design is going to be quite complicated, you might be better off to start with that. Also, it supports new AWS services more quickly than CloudFormation does. So if you know that you're going to be relying on new things that AWS are putting out and you want to iterate your things quite quickly, Terraform might be a better choice than there. I don't have an example for Terraform. It's not quite as readable, and it's a bit too much to actually fit on one slide. So, onto the security domain stuff. So at the absolute bare minimum, the simplest thing you want to do is you're going to want to have some kind of audit trail to give you an idea of what's actually going on in your AWS account. So the service that you want for this is Trail, and that tracks everything that hits the AWS API. So it's not going to record things that are actually happening on your instances unless they're doing something that hits the AWS API, which is things like users doing it through the command line, the web console, or a Python app that you're running that uses an AWS SDK to actually interact with your resources. So now it is enabled by default on all new accounts, which is a relatively new thing, and you get 90 days of history for free. But if you do want to keep your records for longer, which you really should, you can configure it quite easily to save them into S3 for you. You can see there's a little screenshot there, it's really small, of the kind of data that you get recorded. Basically every API call that you make to AWS will get recorded, along with some kind of metadata around that, like the time of it, the source IP that you've made it from, and things like that. So the best practices for that, configure it to log to an S3 bucket. Ideally, and if you've got a really sensitive environment especially, take those logs and put them in a totally different account. So even if the account that you're using gets compromised, your logs are in a completely different place, you can see exactly what's going on. You're going to want to encrypt them as they're stored, that's just a tick box. And you're also going to want to enable a feature called log file validation to ensure that if you do need these logs for an investigation later on, you can verify for sure that they haven't been tampered with to remove or modify evidence of what's actually happening. So, this log file validation thing sounds kind of interesting. How does that actually work? So, over time, CloudTrail will deliver log files into your S3 bucket. Every few minutes you get a new JSON file with more logs. As they get delivered into your account, AWS keeps track of the hash of each of these files as they get delivered to your account. And then every hour, AWS delivers what it calls a digest file to your account. And what that is a big list of references to all that hour's log files and the hash of those files. This digest file is signed by AWS with a private key that they have. So that means if any of the individual log files on the left get tampered with or modified, the hash isn't going to match the one in the digest. And if you try to modify the digest file, then it won't pass its signature verification. So you can tell that something somewhere has been modified. Another nice touch they have, each new digest file that gets delivered contains the hash of the previous digest file. So really quickly, it becomes completely infeasible to actually tamper with those logs in a way that you can't later verify. Moving on, another logging and monitoring service that you're definitely going to want to turn on is Guard Duty. So that performs kind of automatic inspection of what's happening in your CloudTrail logs and also any network traffic that's flowing between your resources. It takes a few days for it to learn kind of what your usage and your traffic patterns look like. And after that, it can detect kind of anomalous events that don't match your usual activity for the account, which could indicate something amiss on some of your resources. So these are all the finding types that Guard Duty can spot, which gives you an idea of the sort of genres of issue it can be used to find. They keep expanding this list, so it's quite up to date and relevant most of the time, and it's pretty extensive. So let's take a look at some concrete examples of actual findings that you might have with this. So some of the examples we've got here, an EC2 instance querying a domain name that's associated with cryptocurrency related activity. So the way that probably works is when you deploy an EC2 instance, by default it's going to use AWS provided DNS servers in the subnet that you put it in. So AWS can inspect that traffic, you can see where your instances are calling out to and flag that up to you if there's anything malicious there. An API being called with root credentials. So remember at the start, we wanted to make sure that we really didn't use the root credentials anywhere. GuardDuty gives you a really easy way to determine if someone is using them when they shouldn't be. An instance generating larger amounts of traffic than normal. So because there is a machine learning component to GuardDuty, it can build a profile over time of what sort of things and what sort of activity your resources generate, and kind of build a normal baseline. So anything that deviates from that, it can alert you to as well. And then finally, Cloudtrail being disabled. So given that we know it's kind of the main auditing tool, it's really nice to get an alert when that happens, because there is really unlikely to be a legitimate reason for that being turned off. So if you are interested in this stuff, go and have a look at the AWS docs for GuardDuty. They publish a whole list of every single finding that they can generate. And it's a really good way to get an idea of what sort of issues can occur in your accounts. And from that, you can then start thinking about how you would protect against these sorts of issues. The first best practice for GuardDuty is pretty straightforward. It's just to turn it on. It is a paid-for service, but it runs as a free trial for the first month, so you can work out how much you're going to end up spending on it. And it's not much. It's generally kind of single-digit dollars, even for a pretty large account. I don't know why they don't just make it free and turn it on by default, to be honest, because it is really useful. Next up, true AWS fashion, they've introduced terminology that they don't really use anywhere else, and that's the concept of master and member accounts. So that basically means you can turn on GuardDuty in all of your accounts, but you can nominate one as a master, and that can collate all of the GuardDuty alerts across all of your accounts for you. So you only have kind of one dashboard to see all of the things that are going terribly wrong across all of your accounts. And then also remember, it's a regional service, so you do need to turn it on for each region separately. There's not much point in just turning it on in the regions that you use, because someone who has compromised your account will be able to determine the regions that you've got it turned on in, and then just do all their stuff in a region that you're not using and you don't have GuardDuty enabled for. And a final one that is worth a mention, it's not actually an AWS product, it's worth a look just based on how easy it is to get it up and running in our experience, and you can get quite actionable results pretty quickly out of it, is CloudSploit. So that scans your resources and generates a big list of findings for you where you're deviating from best practices, or you have things like open ports that could present a risk or vulnerability for you. So the actual scanning engine itself is open source. You can set it up and run it for free, and they've got a kind of paid for UI that sits on top of it. But if you're in a rush to get something up and running really quickly and you just need an idea of what your space kind of looks like, it is worth a look. So I want to touch on encryption now that we've gone over some monitoring stuff. Everybody loves encryption, apart from the government. But it's, and we all know it's important, but it's also really easy to screw up. So in general, AWS gives you enough guardrails and handholding that it's easy to use and you can't really screw it up. For most services, it's just you kind of tick a box and it's done. And it also never costs anything extra to turn it on, so it's always worth doing. But having said that, you can use some of the more foundational tools that AWS give you to build something that meets your more complex requirements, maybe for compliance reasons. You've got really sensitive data that you need to have encrypted in a way where you can verify exactly how everything works and audit how the keys are used and things like that. So the service that you want for that is KMS, the Key Management Service. And this is a service just for creating and managing keys, but you then have much more control over them than the default keys that are used when you just use the tick box encryption. So using this, you can define through IAM who can manage the keys and also who can use them as separate things. So some services like S3 support this natively, so you can configure S3 to use these KMS keys that you're managing to do your encryption as you upload files. And we'll see in a second how that can provide a kind of additional layer of protection for your data. And then finally, there is an AWS encryption SDK and a command line tool as well, which is really good. You can use it to provide kind of provably quality encryption in your apps, whilst relying on KMS to manage your keys and do the back-end part for you. And that's one of the trickiest aspects to do well. in a way that's both secure and robust, so it's worth taking a look at that as well. So here's a little quick example to demonstrate how you can add additional protection and security to data that you are storing in S3. These sort of techniques do apply to other services, but S3 is just a nice one to demonstrate it with. So we know we can easily enable encryption in S3 with just a tick box. You tick box when you're uploading your files or when you're creating the bucket, and everything is encrypted at rest. Hooray! But the issue with that is that AWS is actually too helpful with this. So the encryption happens totally transparently. As long as you have permission to read these files from S3, AWS will happily just decrypt it for you and give you it. So there's not a great deal of security benefit to it other than protecting against someone literally lifting a drive out of an AWS data center, which is fairly unlikely. So imagine a scenario where we want to restrict kind of how the encryption works. We want some kind of control over the keys and the permissions for how things can be done. So that's where we want to use KMS. So we can create policies around who can use the keys for encryption or decryption or both. And then at that point, you need to not only have permission to use the S3 API, you need to have permission to read the file, but you also need to have the KMS permission to use the key it's encrypted with to actually decrypt that file. So if, for example, you have one team that's managing all your storage stuff and your storage permissions, and another team managing all your encryption and your permissions around keys, to accidentally leak that data or make it available to the wrong people, both of those teams now need to screw up. It's also nice and auditable because as soon as you try and decrypt a file in S3 that's encrypted with a KMS key, it will go into Cloudtrail that you have tried to decrypt a file with that key or you successfully decrypted a file using that key. So sticking with key management, Cloud HSM is a service that you're probably never going to use, but it's a great example of how the cloud gives capabilities to people who never would have previously been able to actually access tools like this. So who's heard of hardware security modules? More people than infrastructure as code. Okay, security audience, of course. So it's a fairly niche device, not that niche apparently, which many of you won't have heard of. Disastrous. But the idea behind that is that it's just for generating, managing, and storing encryption keys securely. And these are really high value keys. These are kind of the things used by like certificate authorities or card payment bodies. It's not a particularly affordable piece of equipment. You can't just buy one off Amazon and stick it in your home lab. They can be like $20,000 to buy or more. So when AWS started offering an HSM in the cloud for $1.96 an hour, it was incredible because suddenly anybody who can afford $1.96 an hour can play around with it. As long as you can afford the $5,000 setup fee that you get charged every time you want to use one. But quite recently, they've got rid of that, and now it is just an hourly fee to try out a really specialist piece of equipment. And for most of us, it's not something that you're likely to just kind of stumble across in your daily role. So while it is probably overkill for most of the things that you'll be needing to do, unless you have really specific and niche compliance requirements or something, you'll be fine to stick with KMS, but it's worth having a look at Cloud HSM because you can play around with some really cool stuff. So, moving on to networking. I'm just going to touch on networking a little bit because it's hard to present a full overview of all AWS networking in a couple of slides. But I will touch on it in the next section as well. So the fundamental service is VPC, or Virtual Private Cloud, which encompasses all of your favorite networking infrastructure like subnets, routing, firewalls, things like that. And as with everything on AWS, you can stick with the defaults and have a pretty easy time, or you can get as really deep into customizing it as you want. So to begin, you're going to define your network address space in terms of like a CIDR block. Then add in some subnets to it. So whatever subnets you fancy, normally at least you'll have public ones for internet-facing services and private ones for services that don't really have any business being directly internet-facing, like a database or something. Then simply define some really simple routing rules. So in all seriousness, what this design is meant to illustrate is how quickly your design can get out of hand and how important it is to keep track of where all your traffic is going and who actually has access to your network or a presence on your network, especially old contractors or service providers that you might have forgotten about. And then once you've done all that, you can spend the next 4 hours debugging why you can't SSH into an instance. So, final section, building a secure and resilient web app is about pawning off as much work as possible to AWS instead of doing it yourself. So there's a couple of important concepts for this section. This is the first one. It's a buzzwordy name. It's a great concept. It's a phrase that AWS love. Undifferentiated heavy lifting is something you're having to do that's taking up your time, but it's not differentiating you from your competitors. It's not making you any money. So there's things like patching a fleet of your EC2 instances, making sure your MySQL cluster is replicating and it's up, or renewing SSL certificates on a load balancer, right? These things don't make you any money. They're not making you unique. Just have someone else do them for you. Next up, one of the core concepts of InfoSec as a whole is the CIA Triad for confidentiality, integrity, and availability. So if you're not covering all of these, you're not truly providing security to the people who are relying on you to provide it. It might be glamorous and exciting to be doing red teaming and hunting for APTs, but it's not all that it's about. Good architectures for applications, especially in the cloud, consider all of these aspects. Another way to put it is that it doesn't matter if your data is AES 256 encrypted if you've put it on one hard disk in a data center that's now on fire. That doesn't matter. It doesn't help. And I'm just going to keep mentioning this. Use infrastructure as code literally all the time, wherever you can. So the scenario that we've got for this is we're building a web app that lets users upload and share images. We have a significant volume of users that are using the app throughout the day in random spikes. It's not really that predictable. And they're globally distributed as well. We know we are going to need large volumes of data storage for keeping all the images, and our app is split into two parts. There's an API that does your user management, your upload and your sharing, and we know from the spec that it can easily be containerized, and then a static HTML front end that runs in the user's browser as well. So what's the worst possible solution that we could come up with for this? So we'll start with this, and then we'll see how we can work to improve it. So let's start off with a single EC2 instance running all of this in a single availability zone in one region. All of the data is stored on one massive unencrypted disk attached to this, and the same instance serves both the front end and the API. So let's try and improve this bit by bit, and let's start off with the front end, because that's one of the more straightforward things to solve. So the problems with that, it's not at all resilient to failure. So the EC2 instance dies, the whole app goes with it. It's a pretty poor experience for global users because the further away they are from the region you've deployed it, probably the slower it's going to be. And it's going to be really expensive to run a large server that's not often highly utilized. So, if we know the content's static and we know we've got loads of it, let's keep it on S3. It's dirt cheap and it's resilient to failure as part of that price. We also want to use Cloudfront, which is Amazon's content distribution network, which for those of you who don't know is basically a massive globally distributed cache that serves content across the world, and it will cache your content at locations nearest to where your users actually are. So now the globally distributed users have a better experience. We're not managing any infrastructure ourselves in terms of things like OS patching, application updates, and we're saving money because we're not using any compute when we don't need to, and the caching that Cloudfront gives us means we'll save on bandwidth costs as well. So where are we at now? We've designed the infrastructure to store the large amount of data that we know we're going to be dealing with, and we've improved the user experience for our base. So we now want to move on to the actual compute and see what we can do about that. So it has similar issues to the front end. A single point of failure. It's still going to be expensive for us to run a big server that has to be big enough for our largest peaks of usage, but for the rest of the time isn't going to be doing that much other than just burning money. Maintaining this instance, again, a lot of undifferentiated heavy lifting. Patching is important, but I don't want to spend any time doing it. And our specific server is also configured quite insecurely, so it's in a public subnet, directly accessible from the internet. The original engineer who set it up didn't really know that much about firewall configuration, so lots of things are just publicly exposed that shouldn't be. So a quick primer on scaling before we delve into re-architecting. Vertical scaling, take your server, make it bigger. Horizontal scaling, take your server, add more of them. So let's focus on resiliency first. So we're going to want more than one server running our application. That's fairly obvious, right? But as we add more, is that not just going to increase the cost? Not necessarily. So with effective load balancing and a well-written application, which we do have because I'm making up this scenario, we can add resiliency, but we can keep the same cost or in some cases even reduce it. So we know at least that it can easily be containerized, so we'll do that. We need to build container images for our app. The best practice here is to try and make them as small as possible so that they only contain the kind of exact dependencies that you need for running your application. So it's going to be dead easy to just pick a regular Ubuntu image off Docker Hub, slap everything on top of that, hope for the best. But that's going to be full of vulnerable applications that your application doesn't need, and CVEs that are stacking up, making your whole application more vulnerable, but not actually adding anything to your app. So instead, try and start off with a smaller distro like Alpine Linux, and add stuff onto that so you know exactly what's in your images. Once you've built the images, we're going to need to store them in a way that they can be deployed, which is a container registry. So we're going to use AWS's one for that as well, the Elastic Container Registry, ECR. That's what we're going to use. It has nice integration with all the other container services, free vulnerability scanning, and we can manage all the authentication between our different pieces of our app with IAM roles. So we're also going to need to pick a way to actually run these containers. So we could just keep them on a big EC2 instance that we've got. It doesn't really give us any benefit. And in fact, just adds another layer for us to manage, the Docker daemon. We could use Kubernetes, but since this is a talk on architecture and security in AWS and not endlessly screaming into the void, I'm going to skip over that because it's just a little bit too complicated. We could use ECS, where you provision a fleet of EC2 instances, and then AWS manage the orchestration running all the containers across that for you. But then you're still going to manage OS updates and everything like that we're trying to get away from. So finally, we've got Fargate, which is basically a fully managed container platform. So you throw your container images at AWS along with the hardware spec that you want to give them, and they just run them for you. There's no underlying infrastructure to manage, and AWS are responsible for the security of all the layers up until your Docker image, your application, which is the bit that you should be securing anyway. So let's go for that one. So an app that is configured to run on Fargate uses what's called a service. So the service manages things like how many containers you actually want deployed, where you want them placed, and we can configure this service to deploy it across multiple availability zones. So that even if we lose a whole data center, Fargate just spins up more containers in the surviving availability zones to manage that load for us. We also want to enable auto-scaling based on some kind of metric like CPU usage, and that means we can run lots of really small containers that scale really granularly to cover our demand. So if you imagine your user demand as a big wiggly graph over time, you want your server capacity, the resources that you're deploying, to hug that graph as closely as possible, so you always have just the right amount of compute provision to deal with your load for the best cost. And then finally, we're going to want to stick a load balancer in front of our new API. So the load balancer will manage which container serves your API requests and help balance the load more evenly across your infrastructure. There's also quite a few security benefits to using them. So you can use them to automatically deploy AWS managed TLS certs. So AWS handles the issuing and the renewal for you. There's more undifferentiated heavy lifting that you're not having to do. It's very simple to configure on them. Things like TLS versions, Cypher suites, is much less error prone than you manually going in and editing Nginx config files or something like that. The load balancer becomes the actual public facing part of your application. It's another piece that AWS are responsible for the security of. And that means your containers can just live in a private subnet, as I've got here, with no direct internet access, because the ALB is kind of an intermediary for you, and that becomes the public facing piece for you. So this was the original architecture that we ended up with. Not resilient, not really scalable, not really that secure. And then, without a great deal of effort, we've moved it to something that looks far more complicated, but we actually have far less hand in actually managing, and we've given a lot of the responsibility over. So the static site is running entirely on serverless infrastructure. We're not managing that at all. AWS are handling it for us. And with the API, we've reduced our attack surface to just the publicly exposed load balancer, and we've got automated failover and scaling running for us. So we're resilient to failures. We can withstand the loss of a whole data center. It's a more cost-effective deployment because the infrastructure tracks the actual server demand. We've handed responsibility for the boring but essential bits to AWS and reduced the attack surface a little bit by only exposing a load balancer instead of a whole bunch of random administration ports. So, the final words. It's good to have some idea what you're doing before you just dive right in. Try and design with the cloud in mind. So don't just build the same thing you'd build in a regular data center environment, because you can build better things on the cloud. And then finally, security is important. you might not always find yourself in an environment that's supportive of that, but you can always make sure that you're at least trying to build the best thing that you can, given your circumstances. Thank you very much. Just before I take any questions, I'm on Twitter at JGM Software, and I'll publish these slides for download. After this, there is a bunch of extra slides at the end with kind of resources and links that could be useful if you want to look into any of this stuff yourself. So if this has been of interest, please go and take a look. Does anyone have any questions? Cool. That was easy. Okay, thanks very much.